Hi everyone, in this video we will learn how to install and implement MLFlow in Ubuntu. I am using the Jammy Jellyfish version of Ubuntu. MLFlow is an open source platform built to assist machine learning practitioners and teams in handling the machine learning process. MLFlow focuses on the full life cycle for machine learning projects, ensuring that each phase is manageable, traceable, and reproducible. There are a variety of ways to access the platform. I am going to show you how to install MLFlow in Python using pip and how to implement MLFlow in a Python script. Let us get into the installation. I am going to bring up my terminal. I am using the Terminator terminal emulator because I need to view multiple terminals at the same time to run the code. If you want to use the Terminator emulator, you can run sudo apt install terminator. First, I am going to update the information for the packages in apt by running sudo apt update. MLFlow does not explicitly require Git, but it is highly recommended to use with MLFlow for version control. I will install Git by running sudo apt install git-y. Next, I am going to install Python, pip, which is a package manager for Python, and venv, which enables the creation of Python virtual environments, using the following command. I will now set up a Python virtual environment by running python 3-mvenv-ml. In this line, I am calling on the venv module and it will create a virtual environment called ml. To activate the virtual environment, I will run source ml-bin-activate. When the environment is successfully activated, you should see the name of the environment pop up in your terminal. Now I can install MLFlow by running pip3 install MLFlow in my terminal. I also have a requirements file for a machine learning script I will use to demonstrate MLFlow. The requirements file can be found in the GitHub repository linked in the description. To install the packages, I will run pip3 install-r requirements.txt. Please note that the packages in the requirements.txt file include PyTorch, which can take up to 1.2 gigabytes in disk space, and it can take a few minutes to install. Now that MLFlow is installed, I am going to run the following command to spin up a MLFlow server. To explain this command, MLFlow server initializes and starts a MLFlow tracking server. Backend store URI specifies where MLFlow stores metadata from experiments. SQLite MLFlow DB indicates that SQLite is being used as the database to store information. Default artifact root specifies where MLFlow will store artifacts such as plots or other outputs, and MLRuns is the directory where the artifacts will be stored. The host, 0000, allows the server to be accessible from any IP address within your local network. Finally, port 5000 is the port that the MLFlow server will listen for HTTP requests. Let us run the command and we will leave it running within the terminal. Now that the MLFlow server is up and running, I am going to bring up a web browser and I am going to search for localhost:5000, and this will bring me to the MLFlow page. MLFlow is up and running. Once we run our Python script, we will see data start to populate. Let us go back to the terminal. Using the Visual Studio Code editor, I am going to open the main.py Python script. The script is originally sourced from the PyTorch repository on GitHub. The code is implementing and training a convolutional neural network to classify images from the MNIST dataset. The dataset consists of handwritten images from 0 to 9 and their corresponding labels. There are a few edits I made to implement the MLFlow tracking within the script. At the top of the script, MLFlow and MLFlow PyTorch are imported. Scrolling down, within this code block we will set up argument parsing using the argparse module. This sets up the command line arguments, and those arguments are then later logged and used by MLFlow. Scrolling down further, we will call the setTrackingURI function from MLFlow. This function will direct MLFlow to connect to the server. In our case, we set the server at port 5000. We will create an experiment with the setExperiment function. This will log all of the runs under the specified experiment name. I will call the experiment MNIST experiment. The start run function will begin an MLFlow run. It will log the specified parameters and metrics. For the parameters, we will log the batch size, number of epochs to train the model, the learning rate, and the gamma value. For the metrics, MLFlow will log the test loss and the accuracy rate of the training for each epoch. Once the model is trained, our code checks that the save model flag is set in the command line when the script is run. If it is, then the trained model will be saved. Using the PyTorch module, we will save the model's parameters. These lines create a dummy input tensor with the same shape as the data the model is expecting. Finally, with MLFlow, we will log the model, register the model name as mnist_model, and provide the input example for MLFlow to infer the model's input signature. And that is our Python script with MLFlow. I am going to go back to my Terminator terminal. To run the script, I will have to activate the virtual environment in my bottom terminal. I will do this using source ml-bin-activate. Now I will run the Python script by calling python3 main.py, and I have to add the save model flag. This will save the PyTorch model we are training. We can see the script is running. We have our first epoch of the training. By default, the script has 14 epochs to train the model. As the model is running, MLFlow is already ingesting the data. If I bring up MLFlow and refresh the page, we can see our MNIST experiment. I can select the experiment, then select the current run. There is some information already populated. We can see the time and date that the run was initiated. We can see who created it. We can see that the status is that the script is still running, and we can see the source of the model. Scrolling down, we have our parameters listed. The model is still on the first epoch, so we don't have any metrics yet, but after a few runs this will populate. Let us go back to the terminal. I will fast forward the video to the end of the training. The training has completed. I am going to go back to my web browser and open up MLFlow. I am going to refresh the page. If I check the status, we can see that the model has finished training, and we can see that it took 13 minutes to train the model. If I scroll down, we can see that we now have metrics for our model. I am now going to select the Model Metrics tab. Within the Model Metrics tab, we have our test loss and accuracy. On the y-axis, the test loss and accuracy values are plotted, and on the x-axis, we have the epochs. Now I am going to select the Artifacts tab. In the Artifacts tab, we have the model directory. This directory contains the files and configurations for a given model which are required to load, deploy, or make inferences using the model. The model schema displays the input and output schemas of the model, which is derived from the input example we created. The Validate the Model Before Deployment tab provides an example script to validate the model inference works properly with the logged input example. Overall, MLFlow can be a great way to log data on your model, and it can be a great method to share with your teammates what your model is doing and how it is performing. Thanks everyone for watching. I hope that you found this video helpful. In the description, I linked the documentation site for MLFlow. If you found this video helpful, feel free to like and subscribe. You can also connect with me on LinkedIn, X, GitHub, Medium, and Odyssey. I also have a new podcast called The Aspiring STEM Geek, which you can check out on YouTube, Spotify, Apple Podcasts, Audible, and iHeartRadio. Thanks again for watching and happy coding.